what we're doing today is looking at an example program, which is a little four-function calculator. And we're looking at this program for two reasons. It says up on the board. First is it's an example of processing deep lists, that is, lists of lists of lists. Because in this calculator program, I can say plus times 3, 4 times 5 plus 6, 7, as deep as I want to go, and it'll figure out the answer. So if you look at that expression as a scheme expression, it's, you know, it's exactly like what you've seen before, but now I want you to look at it as data, and it's a list of lists of lists in some cases, okay? So we are looking at how to handle such a situation. And great t-shirt. You. Also, down the road, we're going to be looking at a scheme interpreter written in Scheme. And traditionally, this has been a big obstacle for students. It's sort of all of a sudden, we're looking at this big, complicated program. And so we now build up to it in little steps. And this is our first little step. So unlike an actual scheme interpreter, this one has no variables, no procedures as first-class things. In fact, it only has 4 procedures you can call altogether, plus, minus, times, and divide. But it's scheme-like in its notation. So you say, you know, plus 6, 7. You don't say 6 plus 7. And it does composition of functions in exactly the way that Scheme does. So although this is very, very, very simplified, most aspects of it are pretty realistic. And the big overarching picture that I want you to get is up on the third board. It's that there are 3 pieces to an interpreter. It has a Y in parentheses there because it's any interpreter, not just a scheme interpreter. Basically, any interpreter for any language is going to have pretty much the structure that you're about to see. And there are 3 parts to it. The first one is a very simple part. It is this, the read eval print loop. If you're a Lisp person, you say REPL, and everybody knows what you mean. You mean this. It's a loop because the last thing in it is a tail call to itself. So this runs forever. And it's a read eval print loop because of this line. And remember that things in Scheme happen kind of inside out. So when Scheme sees this, first it calls the read procedure. And the job of read is to turn things with parentheses into basically box and pointer diagrams, into pairs. So the read procedure gets this example like this as just a string of characters, and it looks at them and says, oh, this is an open parenthesis. That means this person is starting a list, and so on. And it creates the box and pointer diagram the same as you should be able to do. And then the result of read is given to eval. It's actually called calc eval so that it doesn't get confused with eval that's an actual STK primitive. So this is calc eval, but it's the evaluator, the core of the evaluator, and it takes an expression as its argument, and what it returns is the value of that expression. And what do we do with that value? We print it. We call print. So that's why you actually see a 77 there. So read read the expression that you typed, eval calculated the 77, and then print printed 77. Okay? So questions about the REPL? Great. Easy, right? This is the easy part.